Hello, my name is Max Denton. I work on the MediaConvert team at AWS, and here we're showing off a few conversions that MediaConvert is doing for file-based transcoding. So the first up here we have Automated ABR Configuration. And the idea behind Automated ABR Configuration is that when you are trying to deliver the best video quality at the lowest bit rates, the adaptive bit rate ladder, as we call it, so these rungs at different resolutions, different bit rates, and even different frame rates, the ideal configuration of that ladder is dependent on the technical aspects of the content and also on the visual complexity of the content. And so we're showing here how instead of having manual tuning or optimization of multiple profiles be used to create these highly optimized outputs, we're doing all of this automatically inside of MediaConvert. So I'll start at the beginning here and just show you the sort of highly simplified interface that we use for Auto ABR. So as opposed to building out the rungs of this ladder individually, setting your resolutions, setting your bit rates, we've just got this pane here where you turn on Auto ABR and you answer a few simple questions, primarily giving it a upper bound and lower bound for the bit rates that you want this Auto ABR ladder to be spread across. Upper bound is ultimately going to determine for high quality content and users with the fastest internet connection speeds just how many bits you're willing to spend delivering that video content to the customer, which ultimately means how much your CDN costs will be to deliver that content. And then the minimum bit rate really says just how low a video quality, video bit rate do we need to put at the bottom of that ladder so that you can deliver to audiences with lower speed or less stable internet connections. And so in this example, we configured MediaConvert to go from about 600 kilobits up to around 7.5 megabits. And then we gave MediaConvert three very different pieces of content. So here we have our friend, the Big Buck Bunny, a piece of animated content. This is actually a 60p version of Big Buck Bunny. Then we have our other friends from Crowd Run. So here we have thousands of people running through a crowd. This is an incredibly difficult to encode piece of content because of the visual complexity. And then we have a clip from the Grand Tour here. So this is episodic television content, and it's actually at 24p, so lower frame rates. And so we're going to look at how Auto ABR and all three of these pieces of source content were run through exactly the same job configuration. And we're going to take a look at how Auto ABR delivers different results customized to the complexity of the content. So just at a glance here, we see that with Big Buck Bunny, we were able to go all the way up to 1080p, given that constraint of 7.5 megabits. Auto ABR works in 4K as well, if there's a higher bitrate budget allocated to the ABR ladder. And you'll notice that with the ABR ladder for Big Buck Bunny, largely the video is scaled at pretty high resolutions because the content easy to encode. There's lots of sort of vector content. The animation encodes well. And so we're able to deliver a lot of pixels to the end device. Compare that with Crowd Run here, where we have this clip with an incredible amount of visual complexity. Auto ABR actually determined that at that 7.5 or 7.6 megabit range that we gave it, 1280 by 720 or 720p was actually the best resolution and allowing the end device to upscale this. And so if you took this version of Crowd Run at 1280 and then let's say manually encoded a different version at that same bit rate in 1080 and compared side by side, both upscaled to your monitor's resolution, you would in fact find that the lower resolution version preserved more detail because otherwise you essentially are asking the encoder to sort of overextend its bit budget and you lose detail. And so that would be an example of what might have happened if you had a fixed ABR ladder. Here with Auto ABR, we've optimized those resolutions automatically. You'll also notice that Auto ABR, because of the complexity of the content, injected additional rungs into this ABR ladder, whereas compared to Big Buck Bunny, you have a much leaner ladder. And then something interesting happens here with Grand Tour. So Grand Tour being 24p based content, there's a lot less frames to encode, but it also means that your end viewer is looking at each of those frames longer. And so here, given the lower frame rate and the same bitrate budget, we were actually able to achieve even our second tier, this is about a 3.5 megabit rendition at a higher bitrate. So we'll just step through and take a look at these quickly. And so over on the right, we're showing sort of a best effort at a fixed ladder that would be optimized for all three of these pieces of content. But the truth is there is no one ladder that you could manually configure that's ideal for these three pieces of content. So on the left, we're showing you the ideal ladder that Auto ABR configured for you automatically. So with the fixed ladder here, you'll see these bit rates. You'll notice in the next two examples here, the resolutions and bit rates don't change, constant across the content. In Auto ABR here, again, for Big Buck Bunny, larger resolutions, note the lower bit rates relative to the fixed ladder. Because the content is easy to encode, if we tried to use a one-size-fits-all approach, we would likely be spending more bits than are necessary. Then when I go over here and we take a look at the crowd run clip, here you see, again, that example I talked about, whereas the fixed ladder would still be encoding 1080p at 7 megabits, Auto ABR actually downscaling the content at 1280 to preserve more detail in the encoding, and you'll notice this all the way down the rung, all the way down the rungs of the ladder. You could actually take a look comparing the very bottom rungs of these ladders near the minimum bit rate. These are both incredibly small pieces of video at this point being played back on devices in really bitrate constrained environments. But if you compared the Auto ABR version at the 360 by 202 to your fixed ladder version at 640 by 360, both upscaled to the end device, you would in fact see more detail preserved at that highly constrained bit rate. With this clip, you would see faces and text and logos preserved that are completely distorted when you try to take this particularly complex clip and encode it at a larger resolution. So again, Auto ABR adapting to the complexity of the content, all with a single flip of a switch. And then finally here in Grand Tour, we have something a little bit in the middle. Again, 24p here. So we're kind of taking the bits that we're saving because there are reduced frames and reinvesting them in higher quality encoding in the frames. And so we see here in our Auto ABR ladder, we're actually saving a little bit of bit rate automatically. This is the sort of optimization Auto ABR finds across a large library of content. The 3.5 megabits rung is actually still 1080p as well, and largely pretty large resolutions down the rest of the ladder. So in summary, Auto ABR really here finding the benefits of optimized encoding in regards to trade-offs between resolution, bit rate, and even frame rate across content, all so that you can get the highest quality content delivered at the lowest bit rates with really minimal configuration. If you want to learn more about MediaConvert, check out the link below or log into the AWS console and encode some video.